Solve LEETCODE question 1219. Pass with max gold. In the gold mine, grid size of m multiplies n. Each cell in the mine has an integer representing the amount of gold in that cell. 0 is empty, meaning there's no gold there. And this, I put a grid here in this example, 0, 6, and if you look at here, then this cell means it has 6 gold and an 8 gold and a 5 gold and 7 gold. And return the max amount of gold you can click on the condition. And here are the conditions that you need to keep in mind when you code. Every time you're located in the cell, you will collect all the gold in that cell. So you will take all the 8, take all the 9. From the position, you can walk one step to the left, right, up, or down. So basically, you can walk anywhere, but it's basically only 4 directions and it's not 8 directions. You can visit the same cell more than once. So if you visit the cell, you cannot go back. And never visit a cell with 0 gold. So if it's 0 gold, you simply cannot visit it because there is no gold there. And you can start and stop collecting gold from any position in the grid that has some gold. So you can start from here, you can stop from here. The position, it really doesn't matter. But the goal is to find the max amount of gold in this case. And if you look at here, either direction in this example, right? It said the path to the max amount of gold is 9, 8, 7. So if you go for 9 and you collect a, that's total together is 24. That's the max amount of gold that you can collect in this case. And in the second example, it shows you the grid, and the max example is you go from 1 to 2 and then to 3 to 4 and then to 5 to 6 to 7. That will give you the max amount of gold. And if you go through the, for example, if you go to 4 and then you can go down to 3 or you can go down to 5, but either way, if you go down to 3 and you're not going to be able to move to 9 or to 20, so if you move to 5, it's bigger, and because you move to 5 and you can also go up to 6 and go up to 7. So that's how you get the biggest result, right? You have to also to follow the rules. And this is our interview question asked twice by TikTok in the past 6 months. So when I look at this problem, and the first thing that I would think about is like it's a typical DFS search problem. So we just define the graph, the grid first, and once we define that, we want to run the DFS search no matter what kind of position that we start. We want to run the DFS search. When we run the DFS search, we want to pass 3 parameters. One is the row, and the other one is the column number, and also the amount of gold, right? And then we want to pass the 3 value, and then the amount of gold is basically the current value. And once we pass the current value, we want to calculate the total when it moves down to this neighbor. Let's say we start from 6 here, and then we want to go down. Since 8 is the only position that we can move to, since this is 4 directionally, and we can do this easily in the code to control the direction only down. So it will move to the A. And when we move to the A, right, what we wanted to do is that we want to make sure always calculate, we want to give another value that something like a max gold. So like the max gold is always get updated to either the max gold or the gold, whichever is bigger. And then you want to visit the, when you start the DFS search function, you want to add a cell to the visit set, and so that you won't visit the same cell again. The tricky part is that after you visit the cell and do all these the DFS search function and you also finish the DFS search function on its neighbor, what you wanted to do is continue after you're gonna continue to run the DFS search on this guy, right? But after you go through this guy's neighbor in all directions, what you wanted to do is remove this guy after the entire cycle. You find out the total. For example, if you go through 5A9, this is just one example. If you go through this, right, you want to also remove the original cell from the visit set so that it won't. You want to remove the cell so when you run a different DFS search, it would not visit this cell because it should still be allowed to visit cell. It's basically try to find the max amount of the different combo. You try to get the max value, and I think you will understand this better when I show you how to do this in code. So let me just show you how to do that. And if not grid, we're just gonna roll out some basic C tree like edge cases like the not grid and 0, right? If it's all 0, then we just return 0, simply return 0. So I like to do it this way, and I'm gonna just define a grid here and the grid 0. And then I want to use a visit set to show the things that I have visited. And I also wanted to define a max gold. Max gold is basically the total. Like if I go from 6 to 8, then max gold will be 14. And if I continue to go down, I'll just add the number. It's basically the total, like the max gold. And then I'm gonna define the DFS search function. And like I mentioned, I'm gonna pass the RC and the gold. So the difference is max gold is the total number of the gold, and the gold is current value of the row column we're located at is 6. So let's define that, and then we want to declare non-local for the max gold, and because I put it's a nested function inside of the main function, so I want to say like visit, and after I do that, I will always make sure to update the max gold with either max gold or gold itself, whichever is bigger. So at the beginning, I want to add the visit set of the RC to this visit set when I visit this cell, right? When I visit this cell, I will say for DRDC in all 4 directions, 0, -1, 0, 1, and 1, 0, and -1, 0, right? And then I want to count its neighbor. So neighbor equals to R plus DR and C plus DC. It's basically the R is the original row, right? And then I want to plus basically DR, DC is 0 and -1, so I want to plus each of them so I get the new row and column count for the neighbor cell. And after I calculate the neighbor cell, I want to do the condition check. When I do the condition check, I want to make sure that the row is within, basically it's inbound, and then I want to make sure the column is inbound as well. And I also wanted to make sure that the row or the column does have gold, right? And also the other thing, I want to make sure that the row column not in visit. I have not visited, because if I just visit it, then I absolutely don't want to visit it again. So then if that is the case, I'm gonna run DFS search on the row and column. Here is the tricky part. When I run the DFS search on on its neighbor, right? The gold value, it's not the gold already. It's actually the gold plus the grid row column. That will be the new gold value, if that makes sense to you. So then you can continue on with the depth search with more neighbor and layer. And then after you've done all that, all the neighbors, I want to make sure I remove this RC from the visit set. So when I do a different way of calculating the total, I will always be able to visit the cell that I ran in the previous depth search. So this is the main part for the depth search. Then I'm gonna say, let's say just assign a result equals to 0, kind of like the max gold, like the total amount of gold for R in range of, I'm gonna call the rows, I'm gonna call the depth search function for C in range calls. So if the grid has gold, right? If that makes sense. If grid has gold, I wanna say max gold equals to 0 at the beginning, and I'm gonna run depth search on row column, and the gold value, when I pass the gold value here, it's actually grid RC, basically meaning the cell where I started, the value of this cell, like for example, like 6 here. So then I'm gonna run the depth search function. And the tricky part is that we also need to remember to update one thing, is that when you try to get the max amount of the output, you want to make sure that the result is the max of either the result or actually the max gold, if that makes sense. It's kind of like how you do it in the depth search function, because you're trying to find the biggest. So when you start from different cell, because you're gonna run this from each cell, whichever cell that has gold, and you're gonna start from that node to find out the biggest. And of course, that when you try to find the biggest, that you're gonna have to find a max value between the rest and result and also the max gold. After I run through the entire grid, I will be able to return the result. Yep, it's accepted. Yep. I hope this is helpful. Let me know if you have any questions, and I'll have more video coming for you. Please like my video and subscribe to my channel, and I'll see you soon. Bye bye.